Assalamualaikum everyone. Okay, now let's look at another example in integration by using trigonometric substitution. Okay, look at here, we have this integration of x and then times with the square root of 2 minus x squared dx. So since we want to use the integrations by using trigonometric substitution, so firstly we will write the expression you have here in the form of a perfect square. Okay, so in a perfect square, we will write your 2 minus x squared. It will be square root 2 square minus x squared. So meaning here we have, so this one a is square root 2 and this one you have your x is x. Okay, so next when you write, you will have here it is x equals to, so since we have in the form of e square minus x square, then your x will be e tangent theta, sorry, e sine theta. Alright, so your e is square root of 2 and then sine theta. So if you look at here, we have here is so this one here your x and this one is your e. Okay, next let's look at what is the terms that we need to find in this question. So we have here, we have x here. Okay, we already have your x and then we have x squared. Okay, let's find your x squared. So your x squared will be square root 2 square sine theta. So meaning you will have 2 sine square theta. Alright, square root 2 square and then sine square theta. Alright, continue. What is another thing that we need to find? This one, dx. Okay, so we need to find dx. Thus, we will differentiate your dx over d theta. And then you will get differentiate sine. You will have here, it is negative 2 cos theta. Okay, and when you write your dx as the subject, it will be square root 2 cos theta d theta. Okay, alright, let's continue with the substitution. Okay, now we will substitute all the terms here. Okay, we have x squared and also dx in your question. So we have here, it is the integration of your x is set 2 sine theta and then square root of 2 minus, so x squared is 2 sine square theta. Okay, and your dx is set 2 cos theta d theta. Okay, next we want to simplify the number that we have here. So we have set 2 here times with set 2 here, and when you simplify you will have set 2 times set 2, it is 2. Alright, then the integration of sine theta, the square root of, okay, what happened with your terms in the radical? So we can factorize. It will be 2 1 minus sine square theta. Okay, and then we have cos theta d theta at the back. Alright, so remember, you must find or you must simplify the terms in your radical or in the square root until you will get in the form of this one, that is identity. Okay, so we will modify later on with the formula of identity. Okay, so let's look at here, this one you will get, it is identity. Alright, so let's continue. We have here, it is 2 integration of sine theta, so square root 2, so this one we can simplify. Okay, it is 2 times 1 minus sine square theta, right? So when you simplify, you can write here, we have another square root 2 here. Okay, and then the square root now will be the square root of, if you apply the formula of identity, so we have the formula is, okay, the formula of identity we have here is, okay, 1 minus sine square is cos square theta. Okay, then continue. We have here cos theta d theta. Okay, next we will simplify here. So we have the number we can put outside. So it will be 2 set 2. Okay, 2 square root 2 integration of sine theta, and then you can simplify here. So look at here, we have square root and square. Alright, again we have here the square root and square. So you can simplify, and you have here cos times cos is cos square theta. And we have here sine theta cos square theta d theta. Okay, now we have the integration of a trigonometric functions. Okay, so for the integration of trigonometric functions, we have learned in the previous video where you have 5 cases for the integrations of a trigonometric function. So in this case, if we identify the power for each trigonometric functions, we have here the power of sine is odd. Okay, and the power of cosine is even. That means this one, it is in the case 1 in your integration of trigonometric functions, right? So for case 1, we need to use SIS, S-I-S. Do you still remember about the SIS method? Alright, so the first step is we will split the sign. So we since we have here is only one sign, so we can skip the first step. Okay, next step is we will use identity for sine square. Alright, since we don't have the sine square, then we will skip the identity, and lastly we will use substitution, right? Okay, so we will use here substitution. Alright, so for substitution, you will use let u. So let u is cos theta, right? Because we use the case 1. Okay, and then du d theta is negative sine theta, and what will be your d theta? Right, your d theta will be the subject since we want to substitute in here d theta. Alright, so we have here d theta is du divided by negative of sine theta. Okay, so now we will have to set to the integration of, so sine theta will remain as sine theta here, and the cos will be u square. So we use here, let's say here u square. Okay, and your d theta is du divided by negative of sine theta. Okay, so next step, you can cancel off your sine theta here, and when we simplify, you will have here it is negative 2 set 2 integration of u square du. Okay, class? Alright, let's proceed with the next step. We will integrate, and you will have negative 2 set 2 integration of u square is u3 over 3 plus c. Okay, and now don't forget replace your u, and you will have it is negative 2 set 2 over 3, and your u is cos cube theta plus c. Okay, next, don't forget your final answer must be in terms of x. Okay, so now we will use the Sohcahtoa formula. Alright, okay, so starting with the triangle, right angle triangle. So let's say we have theta here. Okay, so from the original we have here is x equals to sec 2 sine theta, right? So now we will have here x equals to sec 2 sine theta, but then we will write your sine theta as the subject, and you will have x over sec 2. Okay, so remember the formula. We have the formula Sohcahtoa. 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 Alright, so your sign is opposite over hypotenuse. Okay, so what will be your opposite? So this one, your opposite here will be x, and the hypotenuse here is square root of 2. So by using the Pythagorean theorem, you will have here it is the square root of 2 minus x squared. Right? Okay, so remember your expression here will be similar as in your expression from the original question. Okay, 2 minus x squared. Alright, continue next. We want to find here cos theta. So from the triangle, we can find your cos theta will be, okay, cos theta is adjacent over hypotenuse. So where is your adjacent? It is sec 2 minus x squared over your hypotenuse is sec 2. Okay, so now let's substitute in your answer. So you have here negative 2 sec 2 over 3, and then your cos is sec 2 minus x squared over sec 2 power of 3 plus c. Okay, next we will simplify. You will have here negative 2 sec 2 over 3. So when you expand here, you will get in your numerator, we will have here 2 minus x squared power of 3 over 2. And for this one, you will have it is sec 2 power of 3 or 2 power of 3 over 2. Then you can simplify here. Okay, so when you simplify here, you will have it is negative 1 over 3, 2 minus x squared, 3 over 2 plus c. So this is your final answer. Okay, class? Okay, so in here, look at here, we have 2 square root 2 is equals to your sec 2 power of 3. Okay, that is, you have here 2 power 1 times 2 power 1 over 2. So 2 sec 2 equals to 2 power 1 times 2 power 1 over 2. It is equals to 2 power 3 over 2. That's why we can cancel off this one. Alright, class? Thank you.